Hey guys, welcome back to another video on the IV dose. And since you guys are watching, once again, you're being called the dosers. Yes, I know, like uh, drug dosers, but that's not what we're going for over here. We're going for people who achieve sevens, yes, in IB Maths or AHL. So let's get started with today's video then. Today's video is about quadratic functions, and it's about finding the vertex and the axis of symmetry first. Then we'll move on to the discriminant from the quadratic formula, then positive and negative definite quadratics, and then max and minimum points. So let's get right into it. So let's go over the basics of quadratics. So a quadratic function can be expressed in many different forms and in many different forms. So the three forms that are most common for a quadratic function can be seen over here. So first is your standard form, which I hope you all know by now. It's ax squared plus bx plus c. That is your standard form, and that's how you write it in the standard form, any single quadratic. But then you have another form and another form after that. So the vertex form helps you find what the vertex is. We'll get onto what the vertex is a little bit later. But you just need to remember that the vertex form, I'll just write v for now, is a x minus h squared plus k. And the vertex would then be h comma k. That's how you would find the vertex if you had it in vertex form. And to get it from this form, from the standard form to the vertex form, you do something called completing the square, which I hope you all know by now. Then it comes the intercept form. So the intercept form is gained by factorizing the equation. So the intercept form is represented like this: x minus p, x minus q. That's the vertex form. Intercept form. And the intercept form tells us there are two roots or x-intercepts or zeros of the function are p and q. So roots are p, q. That's what the intercept form tells us. So the standard form basically tells us nothing, but if you convert it to either the vertex form or the intercept form, you can find out something like, if you have the vertex form and you do completing the square to the standard form, you can get the vertex. You can get h comma k, which is your vertex. Your intercept form, if you convert it to that by factorizing, you can get your roots of your parabola. This is a parabola, which is p and q. Then comes the shape of the parabola that you're looking at. So you have a concave up or a concave down parabola. Those are the only types of parabolas that you'll have. So the concave up parabola means that you have a minimum point. This is a minimum point. This is a maximum point. Max. So what does this mean? So the minimum point means that this is the lowest value in your parabola, like 0, 1 is the lowest value that you're going to get. Every single value after that is going to be higher than 0, 1, especially for the y-axis. However, a maximum point means that this is the max value that you can get in your parabola. It means that after this, all the values are less. And this is represented, and you can tell which quadratic is concave up and which parabola is concave down just by figuring out the a in the equation that you have for your quadratic. So I'll go through that now. So if you have ax squared, yes, blah 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 blah, you know this a is positive. So as soon as you know this a is positive, you know that this is concave up, because the values that you will be getting once you plot that parabola, no matter what the thing is after this, if this a is positive, it means that you have a minimum point, as this function that you have over here is concave up. However, if you have a negative ax squared and everything after that, it doesn't really matter, you will have a concave down. You will have a maximum point in your equation. So I hope that makes sense. That's how you tell which function is concave up and concave down. Let's move on. So now we talk about a very important note to remember. This is just the same thing. Remember standard form and remember your vertex form and you remember your intercept form. This is really important to know for your exams. So what is the vertex? So as you can see in the graph, a parabola is symmetrical about a vertical line drawn through its vertex. So this vertical line over here is what it's representing. This vertical line over here is your axis of symmetry for your parabola. That is a terrible line, sorry about that. Yeah, so this is your axis of symmetry. Axis of symmetry, or about your parabola. And this axis of symmetry goes through something called the vertex. The vertex will probably be your minimum and maximum point, usually, but it's not always the case. You could have a parabola which is drawn like this. So your vertex is actually, no, I think usually the most of the questions that you come across, your vertex will be either your maximum and minimum point. So the question is, how do you find out what your vertex is of your parabola? Like you have a parabola, you have a equation, quadratic equation, which is ax squared plus bx plus c, yes? So how would you find your parabola? Boom, that's what it is. That's the equation for finding the x coordinate of your vertex. So you do x coordinate of vertex is equal to minus b over 2a. And you do that, you get that value, and you plug it back into your quadratic equation. So you take this value with, let's say this is 7, and you plug it, so you know x is equal to 7, and that's your x coordinate for your vertex. So you got your v over here, which represents vertex. So you have 7, comma y. You still need to find the y value. So you plug 7 back into this equation and solve for it until you get the y value. That's how you find your vertex over here. And if you want to, if the question asks to find the axis of symmetry, it's just the x value, whatever the x value is of the, well, so in this case it would be 7, so x is equal to 7 would be my axis of symmetry for this equation that I have done over here, for this quadratic. So now let's talk about something called the discriminant. So I hope you all know the quadratic formula by now. It's used to find the roots or the two intercepts of a quadratic function. Yes, so this is the quadratic formula. But the discriminant is not the same as the quadratic formula. The discriminant is represented by something called this side. This is what the discriminant is represented by. Yes, the triangle. No, it's not Pascal's triangle. That's what you're wondering. This is called delta. It's a sign in maths. So delta is equal to b squared minus 4ac. This is what the discriminant. This is the discriminant. Now, I know you're wondering, it's like, why you gotta separate up the quadratic equation? You know, it's a pretty nice equation by itself. Why can't the discriminant just be equal to that? I'll come to that a little bit later in the next slide. So these are some laws around the discriminant that we have. This is our discriminant over here. So we know in the quadratic equation, this is inside a square root function. And we know that delta will never be less than 0. Never. It can be equal to 0, but it will never be less than 0. If it is less than 0, then the quadratic function doesn't exist. Never. Yes? But there are certain rules. So the discriminant can, there are different rules for the discriminant. So the discriminant can be greater than 0. The discriminant can be equal to 0 and less than 0. It can be less than 0, and the quadratic function still exists, but it doesn't have any real roots. So ignore what I said about it can never be equal to 0 over here. Sorry about less than 0. Sorry, it's really early in the morning. It's really hard, man. I'm literally dying out here. Anyway, ignore what I said about the discriminant ever being less than 0. It can be less than 0, but it just means different things. So let's go case 1 first. So if the discriminant is greater than 0, it means that there are two distinct real roots. That means there are two x intercepts. Let's go on to case 2. So if delta is equal to 0, if the discriminant is equal to 0, then it has one repeated root, one singular root, only one x-intercept. But if in case 3, if delta is less than 0, then there are no real solutions, no x-intercepts. I hope that makes sense. This is just the same thing again. It's just that if delta is greater than 0, it cuts the x-axis twice, two x-intercepts. If delta is equal to 0, then the graph touches the x-axis once. And if delta is less than 0, the graph does not cut the x-axis whatsoever. You have no real roots. So the discriminant helps us find anything before actually like plugging into the quadratic formula if you don't have a calculator then. So it's really helpful. Now let's say this is a basic overview of what it looks like on a graph. So the parabola still exists for when the discriminant, the delta, is less than 0. But it just means that there is no intercept with the x-axis. The parabola does not intersect whatsoever. Yeah? But if delta is equal to 0, this can be something, usually how it's represented is at least is x minus 6 squared. That's when you know that this intercepts only once, because it's a repeated root. So if you solve this equation, you get x is equal to 6, x is equal to 6, right? And that is your root repeatedly. This can be any sort of quadratic function that doesn't have the two same roots. So x minus 6, but instead it's x minus 3. So that means these are your two roots, 6 and 3. So you plot them over here. Those are your two real roots. I hope that makes sense now. This is in intercept form, by the way. This is how you represent it in intercept form. So now let's talk about positive definite and negative definite quadratics. So positive definite quadratics are quadratics which are positive for all values of x. So that means it remains above the x-axis. So a quadratic is only positive definite if and only if a is greater than 0. So that means your ax squared plus bx plus c, a is greater than 0, and if delta is less than 0. These are your two rules for positive definite and for positive definite quadratic. But for negative definite quadratic, it is only it's when a negative definite quadratic, let me explain it first, are quadratics which are negative for all values of x. So that means that a quadratic is negative definite if and only if a is less than 0 and delta is also less than 0. Relatively simple. I didn't go into too much detail in this video. It's only like a 5 to 7 minute video that I was aiming for. I've attached some questions for you to attempt over here in your own time. So go through that. I will be posting the Canva slides in the description below. So let me know how that goes in the comment section. And thank you for watching today's video. See you later, dosers.